Okay, we are going to talk about pointer and array variables. Okay, so I'm going to write a simple program. I've defined a character array. Okay, that means we have a character array, 4 elements, right? And we know array means they are continuous indices and they're continuous. And CA is a pointer constant, is a pointer constant. That means always points to the first element. And CA plus 0 is the first element. CA plus 1, pointer constant plus 1 will point to the next element. CA plus 2 will point to the next element. And CA plus 3 will point to the next element. And in this case, if let's pretend the address is in hexadecimal C0 or in hexadecimal, let's say 80. Okay, the address here will be 81. Here it will be 82, and here it will be 83. Remember, it's a continuous memory addresses, right? So if this is a point, this is a pointer now. Okay, CA plus 2 is a pointer pointing to the third element. So what if I want to print, see what is in this pointer? That will have let's say CA plus 2 is a pointer. If I want to print this with %p, I will get 82. All right. If I were to print CA plus, let's say 3, this is a pointer, I'll print 83. Okay, so that is how a character array is declared with continuous memory addresses, and this is a pointer constant, and you can add 1 as a offset to access the remaining or other elements in the array using pointer notation, right? We used before CA with square brackets. That's the first element, value of the first element. CA1 is the value of the second element, right? But these are pointers. They only fetch you the addresses of the cells. So if I want to access the data inside, just like here, so you know how to do that, right? Is dereferencing these pointers. So if I want to print 10 using the pointer notation, we say CA plus 0 asterisk will get me the 10. And similarly for the second, asterisk CA plus 1 will get me the second element. So you need to add the offset to the pointer address. Remember, CA is a pointer. Okay, so wrapping up this one, let me put it here. Go back here. So I have written a program here. Okay, I written two. We don't need this. One is for character addresses of each and every uh, pointer offset. and I have declared another integer array, and I'm printing the addresses of the each and every cell. If you see in here, this is an integer array. This is very important. Okay, let's go back here. This is a character array with the continuous addresses, right? By increasing by 1. I didn't print, actually I didn't compile this for you guys. Let me compile it and show it to you. So if you see the character array, okay, if you see the addresses are increasing by 1, 1, 2, 3. Okay, let me run it again. You'll see no matter when I run, my addresses will be always by 1. See it increasing here. This is a character array addresses, right? This is my character array. What if it is an integer array? Let's go back. Now what if it is an integer array? If I have integer array, IA, that's also 4 elements. Integer means 4 bytes, right? So each is a 4 byte. And remember one thing, each byte, this is 4 bytes, right? So IA plus 0 will get me this 4 bytes, right? Will get me the address of this element. Okay, when I say IA plus 1, it will give me this address, because this is integer array pointer, or what, and when you add 1 to that pointer, it goes to the next cell, okay, in the integer array, and it points you to that address. So if this address is pretend is, let's say, x80, this address will be x84, because there are 4 bytes. This is 81, 82, 83. Okay, and let's similarly pointer add 2 to that, it'll give me that. Okay, so it is 84, 85, 86, 87, 88. This is the address of that. So I plus 3. So this is an integer pointer arithmetic. You access with using pointers, and you manipulate the memory locations using offsets. Okay, now let's go back and see how I have done the same thing, and now you have to understand I'm using the addresses, right? I'm only getting the addresses right now. So let me run it again. Now this time we'll pay attention to the integer array. If you look at the integer array, each location is added by 4. You see that? E8, E4, E6. So addresses increase by 4, just like we saw it here. Yeah? So this is very important. Let me copy that to your PowerPoint. Add to that. Okay? I've added 2. And if you go back to our program, okay, now I will pointer no. Now how do I print? We know how to access the addresses, right? Now how do I print the contents in the array? How do I print it? We know these are pointers. Very easy, right? So this will get me the value stored in here, right? Wherever this is pointing to, if this is 30, it will get me 30 because we are dereferencing the pointer. So that's what this program is all about. We just added the difference between the previous program and this program is I've just added %d and asterisk, right? This program is instead of okay, instead of we printed each and every line, right? I'm just using a for loop now. I've just converted all the printf into a one printf using a for loop. How do I do that? I just did if I equal to 0, ia plus I will get me the addresses. If I use a for loop, I less than 4, I plus plus, right? Then I can access all the elements of the array using a for loop, right? So this is a concise version. So that's a simple. We don't have to pay much attention to that. And yes, here now we are explicitly assigning a pointer variable to a character array. In this example, pointer equal to CA, for instance, if I have character array with 4 elements, we know character array 4 elements means 1 byte, and I'm also declaring another pointer. Yeah, so when I say pointer equal to pointer constant, that means now this pointer is pointing to wherever the CA is pointing, right? So pointer is pointing to wherever CA is pointing. So this is pointing to that. And now I can just do the same thing. Pointer plus 0 will get me that, and pointer plus 1 will get me the next element, and pointer plus 2 will get me that. Okay, pointer plus 3 will get me that. But the good thing is the difference between this pointer and the pointer constant is the pointer constant cannot be changed here. Okay, cannot be changed, a pointer constant. Okay, whereas this pointer is not a constant, it can point to any memory location I want. Okay, here I'm pointing it to CA, but I can point pointer to anywhere in my system as long as it's safe to do it. So I can now use a for loop also. I equal to 0, I less than 4, I plus plus, print, okay, print f, d, it'll print all my array elements if I use that. How simple is that, right? This is a pointer pointing to a array, and we are using a for loop to navigate all the elements. So let's take another example. You got to tell me what is wrong in here. What is wrong in this program? Here I'm declaring a character array with another pointer integer array. Okay, I have a character array, whatever the elements are, we are not worried about that. And then we have an integer pointer. Okay, when you have a character pointer array whatever and have an integer pointer, when you assign pointer to character, okay, array, this is a character array, right? This is okay to do it, but you will end up in problems. But discouraged. Why? Pointer is an integer pointer. It goes by 4 bytes. Remember we talked about it? By 4 bytes. Whereas character array is a 1 byte. It goes like this. Okay? And if your character array is only small elements here, 4 bytes, and you are jumping, whenever you do a pointer plus 2, I'm suddenly from here, I'm pointing here outside my character array. That is dangerous to assign a character array to a pointer array. Okay? So look at these programs I have written and try to implement and experiment in your system.